In the recent past, building a machine vision system required piecing together entirely different worlds. You needed one model to describe a frame, another to draw bounding boxes, and yet another to translate visual layouts into code. Developers spent months wrestling with incompatible frameworks, writing glue code just to force these isolated models to cooperate inside a single application. It was a massive engineering bottleneck. That paradigm is shifting. AI has moved beyond being a component that developers manually integrate. It has become the architect doing the building. This is the Gemma 4 Vision Studio. It's a unified web application housing 4 distinct vision capabilities: analysis, detection, screenshot to code, and structured extraction, all within one interface. The repository's origin is even more striking than its feature set. It was authored autonomously by an AI coding agent named Neo. The era of manual vision integration is ending. We have reached a point where AI can independently assemble and deploy its own comprehensive sensory systems. The application uses a flexible backend. It can connect to the cloud via OpenRouter or the Gemini API, or run entirely on your local hardware through Ollama. It treats machine perception as a hierarchy, starting with Analyze mode. Here, the Gemma 4 model acts as a direct observer, using natural language to describe what it sees or to answer specific questions about the image. Beyond simple comprehension, the system develops spatial awareness through Detect mode, which identifies and locates specific objects within the frame. This logic flow shows a dual-engine architecture. By default, it processes images locally using Facebook's dchar model. If a developer skips PyTorch dependencies, the system automatically reroutes the work directly to the Gemma model. For those without an API key, the application defaults to mock mode. It feeds realistic, pre-generated responses into the interface, so you can test the UI without spending credits or setting up an account. This design ensures functional machine perception is available, regardless of a developer's local hardware or API budget. The third level of the hierarchy moves into functional translation with screenshot to HTML mode. You can upload any flat UI mockup, and the system decodes raw pixels into clean, semantic HTML and CSS that accurately recreates the original design. The apex of the system is pipeline mode, where all of these discrete capabilities synthesize into a single operation. In a single pipeline request, the system simultaneously extracts text, identifies UI elements, and categorizes the image. Along those tracks, it attaches confidence scores and answers questions in real time, compiling these parallel outputs into a structured JSON format for enterprise applications. To maintain stability, the repository includes 19 built-in tests that verify every endpoint and core class without requiring external API calls. Pipeline mode finally establishes computer vision as a reliable data extraction engine capable of handling complex, structured workloads. The Gemma 4 Vision Studio demonstrates that multimodal machine vision is now accessible to anyone with a terminal and a basic API key. AI agents are now generating the very architectures we use to decode our visual world. This accessibility scales from a lightweight local Ollama instance on a laptop up to a massive 31 billion parameter model in the cloud. Every digital image is now a deeply interrogatable dataset containing latent layers of metadata that these models can instantly extract. The foundation has been coded. Clone the open source repository, insert your API key, and begin building the next layer of visual AI applications.